11.8 is about expected value. Let's take a look at this diagram. So we have a circle cut into 3 equal parts, and it has numbers on them: $1, $5, $20. To find the expected value, you would take the dollar amount, such as $1, and multiply it by its probability, 1/3. Then you would add $5 times its probability of 1/3 plus $20 times its probability of 1/3. When you add all these results together, what you're coming out with is a weighted average that can help you decide whether or not you would win money or lose money in the long run by playing this game. So here's a definition for expected value: a mathematical way to use probabilities to determine what to expect in various situations over the long run. So we're going to use the probabilities to help us make hopefully good decisions. All right, so here's our first problem. Find the expected value for the outcome of the roll of a fair die. All right, so our sample space that you have each side represented. These are the numbers that we could roll. And when they say it's a fair die, each side has equal likely chance of occurring. So the probability for each side would be 1/6. So on the expected value, I will use E of X. This just represents expected value. I'm going to take the one side and multiply it by its probability. And we'll just do each side times its corresponding probability. Then we have 4 times 1/6, 5 times 1/6, plus the sixth side times its probability. So when you calculate this, you will end up with 21/6, or 3.5. So in the long run, you can expect an outcome of 3.5 by rolling the fair die. So this problem is asking us to find the expected value for the number of girls for a family with 3 children. So we need to use the table that they provided for us. And the table shows that on the first column, it says the outcome is the number of girls. So 0 girls, 1 girls, 2 girls, or 3 girls, and the corresponding probability for each one: 1/8, 3/8, 3/8, and 1/8. So we're going to take each possible outcome. So I'll say the expected value. So for 0 girls, the probability is 1/8, plus for 1 girl, 3/8, 2 girls, 3/8, and 3 girls, 1/8. So once again, on this table, all we're doing is basically just multiplying straight across, getting our results, and then adding them together. So in this case, our expected value is going to come out to be 3/2, or 1.5. So in the long run, a family with 3 children can expect to have 1.5 girls. An automobile insurance company has determined the probabilities for various claim amounts for drivers ages 16 through 21. So we'll use this table below on the far right to help us calculate our expected value. Part A says calculate the expected value and describe what this means in practical terms. All right, so let's go for our expected value first of all. All right, so it says the amount of the claim. So if we have $0, and we're going to multiply that by 0.7 plus $2,000 claim times 0.15 And we're just going to multiply each amount times its corresponding probability. Remember, the probabilities can be written in a decimal form as long as it falls between what? 0 and 1, and we can include 0 and 1. A lot of information here. I think I have all of that. Let's see. Let me double check. All right, so if we take all of these and do our calculations, our expected value should come up to be $1,100. Right, so our expected value, I'm using E of X. So it says on here, what does this mean in practical terms? So what you can imagine is that on average, this insurance company is going to pay out $1,100 for every claim that comes through for the drivers that are ages 16 through 21. Okay, let's take a look at Part B. Part B says, how much should the company charge as an average premium so that it does not lose or gain money on its claim costs? So we don't want them to lose money, and we don't want them to make money. That's called a break even. We want them to break even. So if our average expected value is $1,100, then we should charge a minimum of this amount, $1,100. So if we charge a minimum of $1,100, we can expect not to lose money or gain money if we're the automobile insurance company. A game is played using one die. If the die is rolled and shows a 1, 2, or 3, the player wins nothing. If the die shows 4 or 5, the player wins $3. If the die shows 6, the player wins $9. If there's a charge of $1 to play the game, what is the game's expected value? All right, so we have a nice little table listed below with what happens when you lose $1 if you roll a 1, 2, or 3. If you roll a 4 or 5, you gain $2. So it has a nice little table on there for us. We're going to grab our expected value just like we've done 2 previous times. So this -1 is that we're losing $1. And there's 3 numbers that cause us to lose $1, 1, 2, or 3. So 3 out of the 6 numbers on that die will cause us to lose $1. Right? And then we can win $2 if we roll a 4 or 5. So that is 2 numbers out of the 6 sides that we can win $2. All right, if we roll a 6, we win $8. So $8 would be 1 number out of the 6 sides that would be a winner. All right, so we do our calculations with this, and you should come out to 3/2, or, and now you put 1.5, but this is money that we're talking about. So my expected value on here is $1.50. So in the long run, you have a good chance of making money by playing this game. This problem states, one way to bet in roulette is to place $1 on a single number. If the ball lands on that number, you are awarded $35 and get to keep the $1 that you paid to play the game. If the ball lands on any one of the other 37 slots, You are awarded nothing, and the $1 that you bet is collected. Find the expected value for playing roulette if you bet $1 on number 20. Describe what this means. So by reading this, I'm understanding that there are 38 slots that have numbers on them, and you place $1 to bet on your number. So this case, we're betting $1 on the number 20. Right? It has a table on the bottom that says if your ball lands on 20, you get $35, and it gives a probability that corresponds to that. And then if the ball doesn't land on 20, you lose your dollar, and it has the corresponding probability for that. So the expected value, using our information from the table, or you might really not need that, you have $35 times 138. Right? The probability one number out of 38 numbers will win. Plus, we have this -1 because we remember 37 out of 38 numbers on the roulette wheel will be losers, and you'll lose money. So if I do the math on here, I'm coming out with a -$2 divided by 38. Remember, just keeping it real with all this money. So we have a negative, and it looks like 5 cents. So you can expect to lose, that's what that negative sign is, you can expect to lose 5 cents on average for playing this game. So this is definitely not a money maker game. This problem comes from a My Math Lab homework, and it's homework problem number 4. And it reads, a store specializing in mountain bikes is to open in one of 2 malls. If the first mall selected, the store anticipates a yearly profit of $525,000 if successful, and a yearly loss of $175,000 otherwise. The probability of success is 1/2. If the second mall is selected, it is estimated that the yearly profit will be $350,000 if successful. Otherwise, the annual loss will be $105,000. The probability of success at the second mall is 3/4. What is the expected profit for the first mall? And then they're going to ask us what is the expected profit of the second mall? Right, so let's find the expected value for the first mall. All right, so let's think about this. For the first mall, if we look at success, we will earn $525,000. And it says the probability of success is 1/2. So this is the amount for success. And then it says otherwise, we lose a loss of $175,000. So this would be a subtract $175,000 times its corresponding probability, which is also going to be 1/2. We have 1/2 possibility of success and 1/2 possibility of failure. So when we calculate this out, we come up with an expected value of $175,000. And this is for mall number 1. Right, then we're going to go grab the expected profit for mall number 2. So mall number 2 states on there that we would have a profit of $350,000 if successful, and the probability for success is 3/4. And it says otherwise, there is a loss of $105,000. If it's not successful, it will experience a loss of $105,000. So again, we're going to subtract $105,000 times its corresponding probability. So if we have 3/4 or 75% goes towards success, that means we have 25% going to failure, or 1/4. And this will give us an expected profit of $236,250. This is the expected profit for mall number 2. So in calculating these expected values, we can ask, which mall do you think the company would be more successful in? All right, so this is actually part A right here, finding the expected value for mall number 1. Part B was finding the expected value for mall number 2. And part C is choosing which mall would be more profitable for the company. So we would choose mall number 2. And in choosing mall number 2, we are going to maximize our profit.